Okay, once again, we're breaking 11.1 into two parts. They want us to look at simplifying radical expressions, and we're going to focus on the first part here, simplify radical expressions using the product property of square roots. The product property of square roots, a radical expression is an expression that contains a square root. A radicand, the expression under the radical sign, is in simplest form if it contains no perfect square factors other than 1. The following property can be used to simplify square roots. For any numbers a and b where a is greater than or equal to 0 and b is greater than or equal to 0, the square root of the product ab is equal to the product of each square root. Yeah, not that helpful. This is a little bit more helpful. So the square root of 4, we could break up square root of 4 times square root of 25 is square root of 4, which is 2, times square root of 25, which is 5. So we're looking for factors that are perfect squares. We could go all the way down to primes to find them. Let's see, it's even, so I know I can divide by 2. It's still even, so I can divide by 2. So I've got 2 times 2 times 13. Or we could have just done square root of 4 times square root of 13 because 4 is a perfect square. Either way, the square root of 2 squared is 2, or the square root of 4 is 2. Now the square root of 13, we're just stuck with that. We can't do anything about that guy. So 2 ways to solve the same problem. The quickest way to do this one would be square root of 36 times square root of 2, which is 6 square root of 2. Now I'm sure a lot of you have already figured out your calculators will simplify radicals, but it won't do anything about variables. And it also won't simplify any more than 3-digit numbers, I believe. Okay, so let's look at this guy. If we go all the way down to primes, I could rewrite 24 as 2 cubed, so 2 times 2 times 2 and times 3. So I've got 2 groups of 2 squareds, so that's going to be square root of 2 is 2 times 2 is 4, and I'm left with a square root of 3. Another way of looking at the same problem, square root of 2 times square root of 24 is square root of 48, and we could rewrite that as 16 times 3, and the square root of 16 is 4. A lot of different ways to approach these. The square root of 45, I could rewrite that as 9 times 5. A squared is a perfect square. I could take a squared times a squared and get e to the 4th. B to the 5th, I could rewrite that as b to the 4th. Times b, and c to the 6 is even, so that is also a perfect square. Square root is the same as the 1/2 power, so I can divide my exponents by 2. That's nice. Okay, so I've got 3 square root of 5, and then for my variables, square root of a to the 4th, a squared times a squared would be a to the 4th. B squared times b squared would be b to the 4th. I'm still going to have a b under the radical, and c cubed times c cubed would be c to the 6th. Okay, let's clean this up. Group the things without radicals together. So I have 3a squared, b squared, c cubed, and under the radical I have 5b left over. Kind of like a remainder when you did long division. Now, if we want to be really picky, if we end up with an odd exponent, we really should put absolute value signs around it, but to preserve its positiveness, because c to the 6th has to be positive. So c cubed could be something negative, so if you're really particular, the absolute value should be there. Of the 3 points for simplest radical form, we've only hit the first one. A radical expression is in simplest form when no radicands have perfect square factors other than 1.